The reaction humans thought they controlled. It looked precise, predictable, perfectly measured, a reaction so well understood that control felt guaranteed, until the moment it wasn't. That single fracture between expectation and reality is what defines this story. It arrives quietly, disguised as routine, and by the time it becomes visible, the damage is already structural. To understand why this matters today, we need to revisit how confidence forms in chemistry. When a reaction behaves consistently, trust builds quickly, variables are mapped, outcomes repeat. Success creates the belief that control is permanent, and once that belief takes hold, systems begin to rely on it. That reliance becomes invisible, woven into every decision and design choice that follows. It stops being tested, it stops being questioned, it simply becomes the ground on which everything else is built, and no one thinks to check whether the ground is shifting. At first, the reaction performed exactly as expected. In laboratories, conditions were stable, inputs were pure, timing was exact. Chemistry rewarded discipline with reliability. The reaction became a reference point, a benchmark of mastery. It was the kind of consistency that made ambition feel rational and expansion feel inevitable. Each successful repetition reinforced the narrative that precision always won, and uncertainty was merely a problem already solved. That success invited scale. Factories adopted it. Infrastructure formed around it. The reaction left controlled environments and entered the real world, where conditions fluctuate and assumptions quietly break down. The gap between laboratory precision and industrial reality was not immediately visible, but it was always there, widening with every step away from the original controlled setting. What worked under perfect conditions was now expected to work under imperfect ones, and that expectation was inherited, passed from one stage to the next, like an unspoken agreement no one remembered signing. What made this shift dangerous was subtlety. The reaction did not fail outright, it drifted. Minor variations produced small deviations. Small deviations accumulated. Chemistry was still obeying physical law, but the environment was no longer obeying the rules it had been tested under. The deviation was not dramatic enough to trigger alarm, which made it far more dangerous than a sudden failure would have been. Gradual drift hides inside noise, inside acceptable ranges, inside the margins everyone assumes are safe. This is where the story truly begins. With a reaction humans believed they controlled, now operating at a scale where control depended on conditions no one could fully guarantee. The illusion was not that the reaction worked. It did work. The illusion was that it would continue to work without the precise conditions that made it possible in the first place. As the reaction scaled, its behavior changed in ways that were easy to miss. Variability crept in slowly. Temperature drifted, impurities accumulated, timing shifted by fractions of a second. Individually, these changes meant nothing. Together, they altered outcomes. The cumulative effect was a slow erosion of the margins that had once made the reaction forgiving. What had been a robust process became a fragile one, not because the chemistry changed, but because the distance between actual conditions and required conditions grew wider with each cycle. Engineers responded by tightening control, more sensors, more feedback loops, faster corrections. The system grew more complex in pursuit of stability. Chemistry still worked, but now it required constant intervention. Each new layer of control added its own fragility, its own potential points of failure. The machine designed to prevent breakdown became a machine that could break down in entirely new ways. This is where early tension emerged. Control had become conditional. The reaction only behaved as expected when every parameter was perfectly maintained. Any deviation triggered cascading effects that demanded immediate response. The system no longer tolerated imperfection, even briefly. What had once been forgiving now operated on razor-thin margins, where minor lapses carried disproportionate consequences. What made this dangerous was dependence. Entire processes now relied on uninterrupted precision. Backup options faded. Flexibility disappeared. Chemistry had become a narrow path rather than a broad foundation. The very efficiency that justified the system also stripped it of the resilience needed to survive disruption. There was no fallback position, only the expectation of flawless execution repeated without end. Scientists studying these systems noticed a troubling pattern. Failures were rare but severe. When control slipped, consequences escalated rapidly. The reaction did not degrade gracefully, it snapped. There was no middle ground between function and collapse, no warning and no opportunity for correction once the threshold was crossed. This was the first sign that control had always been provisional. Chemistry could be guided, but not dominated. The belief in mastery had hidden the cost of pushing reactions beyond forgiving boundaries. What looked like strength was actually tension held in place by conditions that could not hold forever. Stability was not a state the reaction maintained on its own. It was a state imposed upon it. The conflict intensified when rare failures stopped being isolated incidents. What once appeared as anomalies began repeating across different systems, locations, and operators. The same reaction, the same breakdowns, different circumstances. The pattern pointed not to operator error, but to something deeper embedded in the design itself. Investigations revealed a shared truth. The reaction was not failing randomly. It was responding to conditions it was never designed to tolerate continuously. Small stresses compounded, micro instabilities aligned. Chemistry followed the rules perfectly, while the systems around it demanded perfection. The mismatch was not between chemistry and expectation. It was between what humans built and what reality would sustain. This buildup carried emotional weight because the promise of control had shaped everything built on top of it. Infrastructure assumed predictability. Safety assumed precision. When that assumption cracked, there was no margin left. Every layer of dependence amplified the consequences. The failure was not just technical, it was philosophical, revealing how deeply the illusion of control had been mistaken for the reality of it. Attempts to restore control pushed the reaction even harder, narrower tolerances, faster response times, less room for human judgment. The system became more rigid, not more stable. Chemistry punished rigidity with fragility. The harder engineers gripped, the more brittle the structure became. This was the emotional peak, the realization that control had never meant resilience, that mastery over a reaction did not translate to mastery over the complexity surrounding it. The reaction worked, but only within boundaries reality could not guarantee. And once that truth became visible, it could not be unseen. What humans thought they controlled was never the chemistry itself. It was a narrow window of conditions, and once the world moved beyond that window, control dissolved into illusion. The climax arrives with a hard truth. The reaction was never truly under control. It was tolerated by conditions that no longer exist. Chemistry did not betray expectation. It fulfilled it exactly. What failed was the belief that control meant permanence. Reactions behave beautifully inside narrow boundaries, but the real world refuses to stay narrow for long. The laws of chemistry never changed, only the context around them did. This realization reframed responsibility. The problem was not the reaction itself, but how completely everything had been built around the assumption of perfect stability. Control became a foundation instead of a constraint, and chemistry exposed the weakness of that choice. The error was architectural, not chemical. The resolution lies in redesign, not regret. Systems that accept variability. Reactions chosen for resilience, not just efficiency. Chemistry guided with humility rather than dominance. The path forward demands building systems that bend rather than ones designed only to hold. Understanding this story changes how progress is judged. Mastery is not forcing reactions to behave forever. It is knowing when they will not and preparing for that moment. True competence lives in anticipation, not in the illusion of permanence. What humans thought they controlled was only ever a moment in time. Chemistry reminds us that permanence is an illusion and adaptability is the real measure of wisdom. Subscribe to join the journey. The